Hi friends, welcome to my channel, and today we are going to study about the gas welding. The content I have taken it from the standard textbook. Just see, I just mentioned that in at the bottom of this slide. First, we will see the introduction. In this, we will study the how or what is the type of gas welding. Second, to carry out the particular type of welding, what all are the equipments used and how we set up them. Next, we will see the different types of flames depending upon the composition of gas used from the cylinder, their temperatures, and its use for the welding for different materials. And the material means mostly the ferrous materials. And that how we will conclude this topic. And at the last, I added the previous year questions from the various exams for your practice. The simple definition of gas welding is that the required heat for melting a material is generated by combustion of gas. That is, we can classify depending upon the use of different gases used for the combustion. First, Oxy Hydrogen Welding. In this, hydrogen will be bond with the oxygen with the generation of heat. Here I have shown the combustion reaction of it. The second is the air acetylene. Acetylene gas and environmental air, is burned to generate the heat. The same way I have shown the burning equation or chemical reaction for that. And the third one is the oxyacetylene. This is the same type as above, but it requires separate supply from the separate oxygen cylinder, for supplementing the oxygen from air. So, in comparison with these three or first two, we are not using mainly in practice. We are not using first two in practice because of various limitations like their air storage, their handling, the temperature generated, etc. We will study the oxyacetylene type of gas welding in this today's video only. There are two types of setups, that is high pressure setup and the second one is the low pressure setup. For high pressure, both the gases are stored in cylinders and both the gases are stored under pressure. That means with a different pressure, oxygen stored at one pressure and acetylene stored at with another pressure. But make a note that oxygen can be stored up to 18.2 MPa as it is not explosive, but we can't store acetylene beyond 200 kPa. There is a chance of explosion. Hence, we need to store the acetylene in dissolved form. And the dissolvent used is like calcium silicate, charcoal, asbestos, balsa-wood, kapok. Dissolvent means like that. You can take an example of sponge which extract water or which can hold a water in that, like that kind of thing. It's porous in nature. Note that 1 liter of acetone can dissolve 24.4 liter of acetylene. Thus, acetylene stored at high pressure in dissolved form. Understood? The next is, no, not next. In exam point of view, they may ask about the storage pressure of each gas. Take a note of these points, what I mentioned in this slide. And the second important point is the color indication of the setup. Just see the side setup. Hose and cylinder color for acetylene is maroon color. If you don't remember the color, then just imagine the gas cylinder color at your home and relate this to it. And hose cylinder color for oxygen cylinder is black and sometimes the hose color is blue as shown. If you don't remember this as well, remember Corona crisis time oxygen shortage and the cylinders we were carrying on. The next setup is low pressure. In this setup, instead of storing a gas at high pressure, the required acetylene gas is manufactured according to the requirement. Okay, and acetylene is generated as per the below reaction. There are two types of generators. Okay, one is the carbide to water, and the second one is the water to carbide. And out of these two, carbide to water generator is mostly used. See side figure for your reference. Water to carbide generator further can be classified under high pressure and carbide to water. Okay, carbide to water is a medium or low pressure setup. If you refer a standard textbook, they have mentioned that to produce the fixed amount of acetylene, how much liter of water and how much amount of carbide is required. Okay, but I gone through the previous year questions and found that it's not that important from exam point of view. So avoid that in detailed study. What I have given here is okay, fine. Next, what are the types of flames, and this depends on quantity of oxygen and acetylene we are supplying. The first is neutral flame. It is generated by supplying a chemically correct mixture, that is the ratio of O2 to C2H2 is 1. In this there are two zones, that is as shown in the figure here, inner white zone and outer blue zone, and this type of flame is mostly used in industry. Okay, and the second one is like carburizing flame. In this, excess amount of acetylene is used and their ratio is 0.85 to 0.95 as shown here. It consists of three zones as shown in side figure. This kind of flame mostly used for hardening operations only. Okay, and the third flame is that oxidizing flame. In this we used excess amount of oxygen. Check the ratio here. This flame has two zones as shown. This flame is mostly used for welding a brass, but not for steel welding. Okay. In this slide, I have mentioned the particular ratio. This is important from exam point of view. Check it out and note it down. In this, I have added the flame, its temperature, and its use in industry. That is how C2H2 and oxygen ratio is increasing and how its temperature is increasing, and accordingly how its or their use in industry is changing. Please make a note of this table or take a screenshot of this, save it for your future reference. Note that in exam there might not be the same figure of temperature. You need to choose the most near or approximate value. In the following few slides, I have given some sample questions from previous year exams. Okay, pause a video for a while and take these questions and try to answer it. Okay. Okay. Thanks guys for watching. If you feel this information given in this video is good, and then please share with your friends and